Okay, so we've talked a little bit about how to determine exponential relations. A couple of ways that we did was, I'll call it method one, okay, is when you have a data set, okay, and if we had, I'll just go ahead and say a function, let's start with 1, 2, 3, 4, and 5, okay, and it had a values of, let's just say 1, 1/2, 1/4, 1/8, and 1/16, okay? So we can look at a data set and we can see that there is a common ratio that is being multiplied by the previous term each time. So in this case, it's 1/2, okay? So as we increase from y, as x goes from 1 to 5, each term increases or decreases in this case by a factor of 1/2, or is being multiplied by a factor of 1/2. So that's one way. Method one is using a data set. Okay. I suddenly mentioned today that another way that you can find out what kind of a relationship you have is you can do it by graph, okay, or specifically a scatter plot. Okay, so I'm going to get another marker. So the data that we had today, which was on the basketball hoops, it was 1 is 17, 2 is 31, 3 is 50, 4 is 85, 5 is 156, 6 we had was 274, and 7 is 498. Okay, and then obviously, if you were to graph this, okay, I'll make a really quick sketch right here, really super small, okay? So if I take a look at my x's, I have 1, 2, 3, 4, 5, 6, 7, okay? And then my y's range all the way to 500, so I'm going to squeeze this. I'll just say it's going to be by 100s, 100, 200, 300, 400. And so if I just really quickly graph this, 1 and 17 is over here, 2 and 31 is kind of like over here, 3 and 50, 4 and 85, 5 and 156, 6 and 274 is over here, and then 7, 498 is way up here, okay? So you can see that we have a exponential function just by plotting the scatter plot, graphing the scatter plot, okay? Well, there is a third method, okay, if we want to determine if we have an exponential relationship, and this third method is checking out, and I'll call it checking out ln of y, okay? So for example, if this is our data set with the basketball, what we could do is we can compare x, and then we're going to take the ln of y. So we have 1, 2, 3, 4, 5, 6, and 7. I don't know if you'll get this on film, but whatever. What we're going to do is if you go to a calculator and you plug in ln of 17, you get 2.83. If you plug in ln of 31, you get 3.43. Okay? If you get plug in 50, ln of 50 becomes 3.91, okay, or 3.912. And then if you plug in ln of 85 into your calculator, you get 4.44. For 5, you plug in ln of 156, and you get 5.05. And then for number 6, if you plug in ln of 274, it's 5.61, and then if you plug in ln of 498, you get 6.21, okay? And what happens is you get all these ln relationships after you've applied the natural log to all of the y coordinates in your original data set. And if you were to graph it, and you end up with a linear, okay, relationship, then you have an exponential original data set. Okay, kind of an interesting relationship. And so what I did was I went onto Desmos and I graphed these points onto Desmos, and I cut and pasted that into your Google Classroom so that you can see, in fact, these values or these coordinates do give you a linear relationship, which implies that the original values are truly exponential.